Hi, welcome to Nomis Academy. This time we'll be dealing with sets. Sets. Set. What do you think a set is? A set is a well-defined collection of objects. A set is defined as a well-defined collection. A well-defined collection of objects. Collection of objects. Collection of objects. So what do we mean by a well-defined collection of objects? Meaning that if we put some objects together, we define them for what they have, for the characteristics that we can tell about them. And it has to be well spelled out such that we can say that this is a set of this that we just said. For instance, we could have a set of primary 5 boys. A set of primary 5 boys. So if we look into that set, we will see that we will not find a girl, and we will not even find primary 4 or primary or any other class that is not of the same class. So a set is said to be a well-defined collection of objects. So let us begin to look into some things we should know about sets. First of all, we should learn about finite and infinite set. Finite and infinite sets. So what do we mean by finite sets? Finite set is a set that has limited members. Another name for members, or another word for members, is elements that have limited elements, that have a particular number of elements. However, infinite set is a set that the elements are unlimited. The elements are endless. The members are endless. What do I mean by the members are endless or the elements are endless? Let's take a look at a set. A set of vowel letters. Vowel letters. So when we say a set of vowel letters, that means in that set I should have A, E, I, O, U. So this is a set of vowel letters. So the elements or the members are limited, are not endless. We can count them. We have from beginning till the end of the elements. What do I mean by elements? Elements are the members of a set. Members of a set. So if I had said that in this class we have a set of primary 5 boys, meaning that all that we have in that class are primary 5 boys. So a set of vowel letters include all vowel letters, which is A, E, I, O, U, and that is all. So this is a finite what? A finite set. Now when we talk about infinite set, now is a set of which the members are endless. Let's take for an instance a set of positive integers. A set of positive integers. So when I said a set of positive integers, where does it start? Maybe it's +1, +1, +2, +3, and where does it end? You will continue until infinity. So the set of this the members of this set are endless. Then we call this an endless set. We call it an endless set. So this is infinite set. Now what do we need to know again? We need to know about subsets and supersets. Subsets and supersets. What do I mean by subsets and what do I mean by supersets? Let's take for an instance. Please note that a set is denoted by a capital letter, while all the members or the elements of a set is denoted or are denoted with small letters. For instance, if I say set A, so set A can be written as this. So I can just write A, set A. Now set A is equal to, if I want to present the element of set A, it must be in a curly bracket. Yes, a curly bracket. And this is what I mean by curly brackets. So if I said set A, let's say we have 1, 2, 3, 4, 5, 6, and let's say we have 7. So this is set A. And I have set B to be 1. I have set B to be 1, 2, 5, and 7. So I can tell, since all the elements in set B can be found in set A, that is, all the elements in set B can be found among the elements of set A, then I will tell that B is a subset of A. B is a subset of A. A is a superset of B. Why? Because A has all the elements in set B without anyone remaining. So we say that A is a superset of B, while B is a subset of A. So that is the difference between subsets and supersets. So let's continue to tell cardinality of a set. So let's go to cardinality of a set. Cardinality of a set. So what do I mean by cardinality of a set? Cardinality of a set simply tells the number of elements in a particular set. The number of elements in a particular set. So if I have set A equals, let's say, in curly brackets, vowel letters, vowel letters, vowel letters. So this set A can be interpreted to be A equal to A, E, I, O, U. So these are the vowel letters. So what is the cardinality of set A? This symbol that looks like N is the notation for cardinality. So I can tell that the cardinality of set A, you can see the way I represented this now, not in curly brackets. Now this N bracket A is telling me that cardinality of A is equal to 1, 2, 3, 4, 5. So just 5. So the cardinality of set A is equal to 5. Is equal to 5. So let's also talk about complementary sets. Complementary sets. What do we mean by complementary sets? Let's take note. Let's say set A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 as as the elements in a set. And we have set B equals 1, 3, 4, 9, 10. And I'm looking for a complement of set B. Now, let's take set A to be our universal set. What I mean by universal set, that is it is a set that contains all the elements we are dealing with. Now, set B is a subset of set A, right? Good. Now, if I will need to find the complement of set B, complement of set B is saying that write out the element of A, that is of universal set, that are not in set B. So if I want to write out the element of complementary set, let's say B complement. So this will be, I have one in the universal set, I have one in the B set, so I will not write one again. But I have two at the universal set, but two is not in my set B, so I will write two out. You can see that. So the next one will be 5, the next one will be 6, the next one will be 7, the next one will be 8. So this is B complement. Remember, B complement is to list out the elements in the universal set that are not in set B. That is B. B complement. Now we need to talk about equality of sets. We need to talk about equality of set. You see, two sets, let's say set A and B, are said to be equal if A is a subset of B and B is a subset of A. Let's for instance say set A is equal to, okay, let's open another page. So let's say set A is equal to 1, 2, 3, 4, and 5. And let's say set B is equal to 5, 4, 3, 2, and 1. So what do you think about the elements of this set? Set A has 1, 2, 3, 4, 5, and set B has 5, 4, 3, 2, 1. So the arrangement does not matter. I can definitely tell that set A is equal to set B. So because all the elements present in set A are present in set B. So this we call equality of set. Equality of set. I believe you have been able to grab the definition of set. You have been able to tell the difference between finite and infinite set. You have been able to tell the cardinality of set. You can be able to tell complementary set, and you can be able to tell equality of sets from this video. I believe you understood all this we did in this video. Bye bye. See you in the next video.